Hello students. In our DME class, we were discussing about levers. Today, we will discuss a numerical problem based on vertical lever. Let's see the statement. A vertical lever PQR 15 mm thick is attached by a fulcrum pin at R and horizontal rod at Q. So in this diagram you can see you have a vertical lever PQR and this lever is attached by fulcrum at R and a horizontal rod at Q. So these are 2 points. This is R point fulcrum and this is Q point where the rod is attached. And the lever has a thickness of 15 mm. An operating force of 900 Newton is applied horizontally at P. So you can see at this point, P point, a horizontal force of 900 Newton is applied. Find reactions at Q and R. So first of all, you have to find reactions at point Q and R. Tensile stress in 12 mm diameter tie rod at Q. So you have to find the tensile stress in the rod which is attached at point Q. Shear stress in 12 mm diameter pins at P, Q and R. So at these pins you have to find the shear stresses. And lastly, bearing stress on the lever at Q. So you have to find the bearing stress. So first of all, you have to find the reactions at Q and R because the force at P is given 900. So given is thickness of the lever 15 mm and force 900 Newton acting at point P. So first of all, find the reactions at Q and R. Let RQ is the reaction at Q, RR is the reaction at R. Taking moments about R we have, so we will take the moments about R. So this becomes RQ into 150. This RQ at a distance of 150 is equal to 900 into 950. Means this 900 at a distance of 800 plus 150 means 950. So we will balance the moments and find RQ reaction at point Q. Similarly, we can find reaction at point R, which is RQ minus 900. So RQ is acting in the right direction and 900 is acting in the left direction. So the reaction at point R will be the difference of these two forces, that is RQ minus 900. That is 5700 minus 900, 4800 Newton. Second thing, you have to find the tensile stress in the tie rod at Q. So stress is force upon area. Force you have calculated RQ 5700 and area is, because it's a rod, therefore it is circular and its area is pi by 4 d square, where diameter of the rod is 12. So put the value of diameter 12 and that is your area 113 square mm. Divide force by area, so you can get the tensile stress which is 50.4 megapascal. Third point, you have to find the shear stress in the pins at P, Q and R. So shear stress, how you calculate shear stress? Shear stress is force upon area, force upon area, force upon area. So force acting at point P is 900, area which is again a circular rod of diameter 12 pi by 4 into d square, and this is your area 113. So shear stress will be force upon area and 7.96 will be your shear stress in megapascal. Similarly, shear stress at point Q, force upon area, because it's in double shear, that's why it's taken 2 here. So force upon area, but 2 is written because of double shear and it's 25.2 megapascal. And shear stress in pin at R, so it is again force upon area. Since this pin is in double shear, so we can take 2 in front of the area. So this is, you can see it is in double shear here in the diagram. So we will mark area twice, that is 2 times area. And the last Fourth point, we have to find the bearing stress or crushing stress on the lever at Q. Again, stress is force upon area. Force you have calculated at point Q 5700, and area is bearing area or crushing area, which is D into T. Diameter into thickness. Diameter of the pin is 12 and thickness of the lever is 15 given to us. So this is your bearing area. So force upon bearing area will be bearing stress, which is 31.7 megapascal. So this completes your numerical and design of vertical lever. Thank you, students.